All right, so we've seen if we have an ortho-para director, we're going to get ortho or para substitution, with para generally being preferred due to sterics. If we have a meta director, we're going to get meta substitution. But what happens when we have multiple substituents? Well, then it depends on the scenario, right? There's multiple available. In one scenario, both groups could point to the same position. So for example, if we have an alcohol up here and a nitro group over here, this alcohol is an ortho-para director. It's an electron donating group. The para position is blocked because the nitro group is already there. So it'll go into one of these two ortho groups. And then on the other side, we have our nitro group. Our nitro group is an electron withdrawing group. So it's a meta director. So it's going to direct to the meta position, right? So we can see in this situation, both groups are pointing towards the meta position. So then when you do your reaction, so for example, bromination, it'll add to the ortho to the alcohol or meta to the nitro. So that one's pretty simple. Obviously, the more complex one is going to be when they point to different places. And when they point to different places, the strongest donator wins. So if you have a donator and a withdrawer, it's going to go wherever the donator tells it to. If you have two donators, it's going to go wherever the stronger donator tells it go to. That's just our general rule of thumb. In real life, you're probably going to get a mixture of products, but we'll keep things nice and simple. So for example, we have an alcohol over here, and then we have a methyl group, right? Both of these are electron donating groups. So this alcohol is going to want to put it in this ortho position because the para is blocked by the methyl. And this methyl is also going to want to put it in the ortho position because the para position is blocked by the alcohol. So when we react it with some kind of reaction, right, in this case, nitration, it's going to go where the stronger activator tells it to go. So it's going to go ortho to the alcohol. And in this case, add a nitro group. And that'll be our major product. Naturally, though, we are going to get some other ones. One more thing of note. We can't add ortho to two groups. So you can't add a substituent next to two substituents. So what do I mean by that? If we had a methyl here and an alcohol here, right, this methyl right here is going to want to go either ortho or para. And this alcohol here is going to want to go ortho or para. This position right here cannot be added to. There's too much steric hindrance between the methyl and the alcohol there. So you can envision three possible products, but you're only going to get two. Right? If we add some generic E+, we could add the E in between, right? That's not going to be allowed. Or we could add the E down here. Or we could add the E over here, right? This one's not allowed. We can't add in between two groups. And again, as I said earlier, if you have multiple groups, it's always the strongest donator that wins, right? So here we have this methyl, and here we have this nitro group. This nitro is going to want to make him go meta, while this ortho group is going to want to go ortho or para, right? So what's going to win out here? Oops, in this case, they're the same. Just scratch that last part. Always remember the strongest donator wins.